The BMV080 particulate matter sensor from Bosch Sensortec is an optoelectronic device, so that means that there are important optical and electronic factors to take into account when you're building it into your end product design. We're going to talk about that now today with Ahmed. First off, we can see, so from the device is, as I said, it's an optical device. It's got a laser and a photodiode inside for capturing the backscattering of light from particles in the air. So optically, it's got to work really, really well. What issues do people need to take into account from an optical point of view when they're doing the design integration?
So when it comes to optical integration, you need the optical integration to make sure that the sensor is functional as expected and also measures precisely. But what's really important is that we need the optical integration in the first place to protect the sensor lens, to make sure it doesn't get damaged or get affected by external contamination. And what you need to let's start with what you don't need first, and then go into what, because it's quite interesting in that the sensor is not sensitive to sunlight or ambient light in general. That means it's not sensitive to sunlight, it's not sensitive to external light, so you don't have an issue with performance because it's a very common question. Engineers are like, okay, what happens with sunlight, or if
So optical filtering is not an issue then?
It's not an issue, and you don't need to take care of that. The other point, which is very important, is that it's a laser class 1, meaning that the sensor is completely safe for consumer products. And that's, of course, a big plus, because it's made for consumer products, so you need to,
you don't need to do any attenuation for protection or anything like that? Okay.
Nothing. So, and then now what you need to consider.
Yeah, so you tell us that. So those are the bits we don't need to worry about, but there are things you do need to take care of.
Yeah, so what you need to take care of is the sensor needs to have a field of view that is free from obstruction. So as you know, it's looking into the environment, so it has an obstruction detection. So if it gets obstructed, the sensor will flag and tell you that there is an obstruction. And that's actually quite a nice feature, so that you can clear the way and make sure that your sensor is measuring correctly. To get more information on the sensor obstruction sensitivity, you can find that in our datasheet with the details of the range and everything. And when it comes to another point to consider, is that you need to have the optical cover at the recommended distance from the sensor lens. And that is also mentioned in our data sheet as well.
And can that does it have to be transparent? Can it be colored? Can it be inked?
It can be tinted, it can be transparent. So you have a variety of options, and we actually provide the recommendations, off-the-shelf recommendations, in our reference design.
So a certain amount of optical attenuation is permitted,
yes,
but it's described in the data sheet.
In the data sheet, and also with the reference design, you already have recommendations, off-the-shelf recommendations, which are easy to find, and they are also we chose ones which are scratch-proof, and so scratch-resistant, and also with good transparency. And we have tested these, so we know that they work quite well. Also, everything that's in our reference design, we have tested it extensively, so you can be sure that it's recommended. If you want to use something else, you're free to do so. But of course, we give you these recommendations so that you get a quick start to prototyping and designing your design.
Absolutely. So we've talked about the optical considerations to take into account when you're doing your design integration. There are also electrical issues as well. Maybe you can describe that as well, Ahmed.
So when it comes to electrical integration, we have several electrical configurations to choose from according to the customer's needs and preferences. It's also related to the use case of the customer. So for instance, the simplest way is to go with a single supply rail of 3.3 volts. That's the most straightforward and simplest way to go. And if you want to save as much power as possible, then you would go for the multi-supply rail option configuration, and that would then save you every microamp.
Yeah, so it's a little more complicated. 3.3 volt is a completely standard, normal sort of power supply arrangement for a sensor, or you might need to for efficiency and power consumption reduction. you might go for the more complicated multi-rail. What are the implications of the
Then
multi-rail approach?
basically, with that, your PCB design becomes more complex,
Okay.
of course. But so depending on your electrical configuration, that will be then translated into how your PCB design is going to be like. It's going to look like at the end. And when it comes to also an addition point, when it comes to electrical integration, is also the ZIF connector, which is a zero insertion force connector. You need to insert the BMV 080 in on where the BMV 080 is inserted on the ZIF connector, and also clipped with a lever to ensure that it's secure in place.
Okay, all right. And on the receptacle side, then you provide a list of recommended products, standard products that are available
In
from
our reference
suppliers
design.
like
In
like,
our reference design, yes.
absolutely. Okay, very good.
Yep.
All right. So we've covered optical considerations, electrical considerations. Then this device also has to integrate with the host microcontroller or whatever. So there are software issues to think about as well.
So the next point to cover would be the software integration, because also you want to communicate with the sensor via software. So the interface, the sensor supports I2C and SPI, and it transferring preconditioned data. And also to access the output, which is PM 2.5 or PM1, you basically access the data through the BMV 080 SDK, which we provide. And the SDK runs on the host controller of the host microcontroller of the customer,
Yeah.
basically.
And are there sort of minimum sort of hardware requirements on the microcontroller to support this sensor?
This is described in our data sheet as well on the limitations of what needs to be done, but we have enabled for quite a lot of embedded platforms, and these are already available with the current SDK.
So are these sort of widely used sort of 32-bit kind of microcontroller platforms that people are familiar with?
To give you an idea of the embedded platforms that already covered and are covered by the sensor are, for instance, ARM Cortex M4F, M4, M33, M33F, also M0 Plus, and you have also support for ESP32. You have for Raspberry Pi, and you have for Windows. And also additional to that, there may be some which I might have missed. And to get the exact, the full scope of all the embedded platforms which are supported, you have that in our data sheet.
Okay, so there's very broad compatibility with
Yes.
with sort of 32-bit
We try to
micros.
enable as much as possible so that the user is, when it comes to software, we provide the SDK, we make it as easy as possible so that they can go faster into their prototyping and then finally the product to reach mass market.
And to be clear, the software integration is in any case straightforward because all of the data processing is done on the chip. It produces a calculated particular
And then you just
measurement.
access the measurement directly from the SDK.
So you're not having to do any of the calculation in your host microcontroller. It's all done on
it's
on
done
the
in the
sensor.
SDK, which is running on the host microcontroller.
Absolutely. Yeah. Okay.
Yeah.
So optical, electrical, and software issues all handled with the advice from Ahmed and the information you can find in the data sheet. Find out more about the BMV 080 particulate matter sensor with this web link. So there's a ton of reasons why you'd be interested in exploring the features of the BMV 080 particulate matter sensor, and you can do so with one of the shuttle boards. So Ahmed, maybe you can tell us, we've got can see the board here, you've got the sensor. I see it's behind an aperture with there's a dark ink glass and some headers and then some connectors underneath. So just tell us, how do you use this BMV 080 shuttle board?
So the shuttle board is meant to be an early evaluation and also for proof of concept. You will find basically it connects to our application board, similar to other shuttle boards which we have in our product portfolio.
So an application board is a board with a microcontroller on it and that can connect to a PC.
Also you can use it for BLE communication, so
Right,
it has a lot of features supported, and you can use it then for proof of concept. So you either use our drivers, we have readily available examples on GitHub, and additionally you can also plug and play. So we have also software supporting plug and play, where you can just plug and test the sensor and see outputs.
Okay, so you can plug this shuttle board into either one of your application boards or into your own proof of concept board, and you've got full software support for it as well, with PC and
Yes.
for support on a PC, and application examples through GitHub and so on.
Yes.
And this board is available for anyone who wants it now?
Yes, and you can get it through our distribution partners.
Thank you.